All right, so we're given two arrays, and the idea is to merge them, which is pretty simple. But one stipulation they have is they essentially want it to be done in constant space. They provide, as you can see here, they provide padding in the first array to fit the elements of the second array. So you don't create a new array that merges the elements, you just modify these elements. So the way I did it was, because we obviously don't want to overwrite these values before we use them, these initial values, what we'll do is we'll actually sort, or rather merge the arrays going backwards. So instead of comparing 1 and 2 and then putting whichever one's the lowest in the right spot, we're actually going to go backwards. We're going to say, okay, so the idea, let me just write this out real quick. So the idea is we have 1, 2, 3, and we'll just call this array like they call it, nums1. Then we have another array, 2, 5, 6, and we'll call this again like they do, nums2. And we're going to have 3 pointers overall. We're going to have one pointer, let's call it I, that will be set to the last element in the first array. Another element called A, and these are kind of arbitrary names. I is kind of supposed to indicate, insertion index, so that's why it's called I. A is just the first array's pointer. B, we'll call it, will point to the last element of the second array. And the idea is, we'll compare A and B, rather the elements at A and B. We'll say which one's greater. Well, in this case, the one at B is greater, so 6 is greater. So we'll insert that element at I. So we'll put it here, and we'll decrement B, we'll decrement I, and we'll repeat that process. And the idea is to repeat this process until either A is down here at -1 or B is at -1. And at that point, that means that we have, if let's say A is at -1, that means we have used all these elements. So we no longer need to compare elements in nums1 to elements in nums2. We can just then iterate through the rest of nums2 and put those elements in here, because these elements are already sorted in non-decreasing order. So we can just put them in at where I is, and then decrement I, decrement B. Same idea is if A is the one still, somewhere in the array, and B is one at -1. It's the same idea. But if we continue this process, and where A is here, we compare 5 and 3. 5 is greater, insert 5 at I. Decrement I, decrement B. Compare 3 and 2. 3 is greater, put 3 here. Decrement A, decrement I. And at this point, we've used this 3, so we can overwrite it, right? So when we compare 2 and 2, let's just pick this 2. We'll insert 2 at I, decrement A. Again, that 3 was already used, so we were fine with overwriting it. And that's the idea of going backwards. We'll always get, when I is at an element, that element will have already been used, so we don't care about losing it. Repeat the process, 2 versus 1, 2 is greater, so put 2 here, decrement B. B is now at -1, decrement I. So now B is at -1. We know we can just go through rest of A and just put each element in I. In this case, it's pretty trivial because I and A are equal, so you're really not going to make many changes, but the process is still important, because if B was the thing that was still over here and A was -1, that's important to do that process correctly. So we have our I pointer, and we'll start that at nums1.length -1, the last element of nums1. We'll have our A pointer, and this one looks like this. nums2.length -1. So the idea is, we know we have 6. Let's go back to the beginning, or more or less. The values aren't going to be accurate, but that's fine. We know we have 6 elements, right? And we know we have 3 elements over here. And we know this nums1 array allows for this, gives enough padding and space to fit nums2 inside of it. So we know that the length of nums1 is 6 minus the length of nums2, which is 3, means we have 3 elements, right, in here that we need to actually keep track of. And because arrays are 0 based, they start at 0, we'll actually have to do a -1 to get the element at the correct index, right? If it was indexed like 1, 2, 3, then obviously we know we have 3 elements. The third element is going to be index 3, and that's all fine. Because it's 0 based, we just have to subtract 1. This will give us 2. This will give us the index of the last relevant value. And then B is trivial. It's just nums2.length -1. And now we'll just go through, and we'll pretty much say, as long as we don't have any index as -1, we'll just keep doing this process. And I don't know if I would ever become -1 before these two, but just to be completely safe, I put that in there. So we'll compare the element pointed to by A, compare that to the element pointed to by B, and if that element at A is greater than the element at B or equals, it really doesn't matter which one. When they're equal, it doesn't matter which one you use. You just kind of have to pick, either use the A or use the B. I chose to use the A. So what you'll do is say nums1 I minus minus, which means the element pointed to at I is going to be replaced by the element pointed to by A, and the minus minus is just shorthand for we could have done this, right? We could have done like this, which is same thing, and then we could just say I minus minus A minus minus, and I just saved a few lines by doing it here. And the same idea with B. And I like to comment this just to make it clear what this else is doing. And this would be when nums A is less than nums 2B. So the same idea above. Again, we're using nums1 here and here because the idea of the problem is nums1 has space for merging the array. That's why we're using nums1 in both cases. But in this case, actually I forgot this up here. In this case, we'll actually use nums2 because that's where the element pointed to by B exists. And now once we're done with this loop, we know either A or B is -1, which means whichever pointer is not -1, we just need to use that to then go through the rest of that array and get all those elements, put them in the appropriate location in nums1. So we'll just do while A is greater than -1. We'll just do the same process as above, right? Oops, I minus minus, not minus II. Same idea with B. And obviously these while loops are just kind of quick. It's a non-redundant way of doing, pretty much an if and then a while. You could have said while A is greater than -1, and then if that's true, then while A is greater than negative, but that's not necessary because this initial while is pretty much an if and a while together, right? If A is equals -1 or less, then this while loop's never going to run, so it's the same as a conditional. And because this is a void function, and the whole idea is to do this, this should not return, and the final sorted array should not be returned, right? You want to kind of, in constant time, or rather in constant space, modify nums1 to have the arrays merged within it. So we're not returning anything because nums1 is just modified. And this time complexity should be, I suppose it really is, the worst case scenario, it would be m plus n, where m, like they said, which we actually ended up not using these values, but m is the length of nums1, n is the length of nums2. So worst case scenario, or rather every case scenario really, you go iterate through the entirety of this array and the entirety of this array. So, and space, like they want, is constant because we're not using any data structures outside of the things they provided. We're not making it. If we were making a new array, then the space would actually be O of, I believe, m plus n. But because we're using constant space, it's O of 1.